Hi everyone. So this video is to help people understand the worksheet that we have right now, worksheet number 2 for our last chapter. Um, for the structure of this, it's going to be the same question every single time. It's just the numbers and the givens are going to be different. So once you learn how to do it once, it'll be fine for you going forward. So you can see we have a little diagram over here. Let me just, yeah, we have a little diagram right up here. So we have a charge at position -5, a charge at position -2, and a charge at position +2. And in the prompt, they will tell you what the charges are. So A in this case is +16 NC, B is -36 NC, and the last one is -54 NC. So before we go through anything, we can actually start doing the givens. This given right here, the K, that's a constant that's going to be used for every single problem. And here we have QA, QB, and QC. Notice the letter in front is the letter N, and for us that means 10 to the -9. The different prefixes mean a different exponent, but for us in this case, N stands for -9. I'm not putting here the positive and the negatives in the givens because this is just going to be used for the math, and we're going to use the positive and negative in a different context for the first question. So the first question they want you to do is they want you to draw a free body diagram for each charge. So if I go back for a second and look at the givens, it does say A is positive, B is negative, and C is negative. So for getting the numbers, I'm just going to look at this kind of diagram. A is positive, B is negative, and C is negative. Now, with this whole thing of Coulomb's law, we need to remember that positives and negatives love each other, negatives and negatives hate each other, and positives and negatives hate each other. So it's all about, do things want to come together or go apart? So let's talk about the first possible combination, A and B. A and B are opposite charge, so that means that they actually love each other. They want to get closer together. So A is being pushed towards B, and B is being pushed towards A. Notice I'm color coding this so that you could see where the arrows are partnered. The next combo we have B and C. B is negative, C is negative. They hate each other. So B is getting pushed away by C. C is getting pushed away by B. And the last combo we have um, is A and C. A is positive, C is negative. They love each other, so they want to go towards each other. And once again, you could see the three sets of arrows, the three different colors, the combo of letters there that we have. What we're going to start doing now is calculating how strong these are. And we're going to go one at a time. So we're going to start off with this first one, A and B. So here we have our givens copied from the first page. We have our number line that was given to us before. And we have the equation to find the force between A and B. So notice I have the equation written up here. I'm taking these numbers, I'm plugging them in for my givens. And the only little hiccup we have is we don't really talk about an r squared yet. So the r squared is actually going to come from this picture. A is at -5, B is at -2, so they're 3 spaces apart. And that's where this 3 comes from right here. So as we clean this up, 3 squared is 9. We have this setup. We can go through our spaces. And we get, if you do the math correctly, 576 times 10 to the -9 for the AB, the red one we had before. Um, you could put this back into standard notation, but we're going to wait till the end to even talk about that. Basically, we repeat the process for the other ones. So here we're looking at B and C, and I'm replacing B and C's with the correct numbers here. And in this case, the R is not going to be 3. We have a different R because we're looking at a different part of the number line. Our R is going to be 4 in this case. So 4 squared is 16. You can handle doing this math with the exponents and the base numbers, and we get 1094 times 10 to the negative 9 newtons for the force between B and C. And just like that, the last one, we could do it for the green arrows before the A and the C. So there's A and there's C. We're going to use the correct givens. And in this case, the R is going to be 7 because there's 7 spaces between A and C. 7 squared is 49. We do the math and we get 159 times 10 to the negative 9. So here's a little summary about what we have right now. We have our pictures from question A, and we have our 3 forces that we got. And once again, it's the same setup every single time. It's just going to be different arrows. It's going to be different numbers that we're going to compare. Notice I have it color coded. So the A and B are the red one, the B and the C are the blue one, and the green is the A and the C there. The first question, now that we're done with this part, they're going to ask you is find the force on A. So we can focus on A first. These all have the same exponents and the units, so this is like terms. So for argument's purposes, I'm going to ignore that part for now. The red arrow had a value of 576. The green arrow has a value of 159. They're both going to the right. They're both going to be positive. So to find the net force, I just add those numbers. And if you add those numbers, you get 735. That's my final answer, so I can add the 10 to the negative 9 back in newtons. So the total force on A is 735 times 10 to the negative 9. A, if we let it go, is very clearly going to go to the right. B is the same process. I'm focusing my attention on just the picture for B. B has 2 arrows to the left. In this case, the 576 and the 1094. Both of them are to the left this time, so I have negatives. I get my final answer of negative 1670, and I add in the like term part of this, the times 10 to the negative 9 newtons. Once again, these are both going to the left, so that's why you see the negative signs here. The last one, though, we have a fight. We don't know which one C is going to go to, so that's why we're doing all these calculations. So in this case, the green arrow is 159. The blue arrow is 1094. Here, when I'm showing my math, 1094 is positive because it's going to the right. Negative 159, negative because it's going left. If I put those together, I get a total of 935. Notice my answer is positive because this number is bigger. So C, if we let it go, would actually go to the right. And then I'm adding in the exponent units here. So as I said, the order of the questions is going to be the same. What they're asking you is going to be the same. The only thing that's going to be different is the original prompt. So these numbers are going to be different up here, and these numbers are going to be different in the problem. Worksheet 2 has at least 6 examples of this with different combinations of stuff to look at. So hopefully this video helps you understand and can be used as a little study guide. Thanks a lot.